My name is Mi-Hui Cho from Gyeonggi University. I will present the paper entitled Production and Perception of Single and Double Consonant Letters in English Words by Korean Learners of English. The English language does not show spelling to sound correspondences. For example, the sound sh is spelled by different letters, as in shop, ocean, machine, sure, mission, nation, conscious. Also, the same letter S is represented by different sounds, as in sugar, vision, sail, resume. In the modern language, double consonant letters do not represent consonantal length, although consonant length is contrastive in the Old English period, whereby single and geminate consonants represent short and long sound respectively. Recently, Bassetti conducted a series of experiments that investigated orthographic effects on the production of English words with single versus double consonant spellings. And they found out that the native Italian speakers produced the target English consonants with double letters as longer as in kitty than the target consonants with single letters as in city. This is different from the production of the native speakers of English, thus showing orthographic effects. Motivated by Bassetti's finding, the current study investigates whether single versus double consonant spellings can cause Korean learners of English to make a contrast that does not exist in modern English in their production and perception of English words. Importantly, the current study expands the scope into both modalities of production and perception to see whether orthographic effects wield the same power over both modalities, since little is known about the extent of orthographic effects on L2 speech perception. Thus, production and perception tests were conducted. The methodology of the test is as follows. Participants were 28 Korean learners of English, recruited from an English class for freshmen at a university. The target English consonants were 6, as in Table 1. So the sound P is voiceless sound and M is voiced sound within the same place of articulation, namely bilabial place. Also, the sound S is voiceless while D is voiced. Likewise, K is voiceless and G is voiced. The stimulus words were 30 English words containing target consonants spelled with either a single consonant letter or a double consonant letter. So for the target sound P, single consonant letter and double consonant letter were used. Likewise, for the speech sound to single consonant word, double consonant word adopted. With the perception task, the stimulus words were recorded by one familiar native speaker of American English. The native speaker's production of the stimulus words were manipulated so as to lengthen the duration of the target consonant twice using the application program. Figure 1 presents the native speaker's production of the stimulus word Abby. The upper panel, this part is the target consonant. The upper panel is the original production of the native speaker, and the lower panel is the manipulated version in which the target consonant B is artificially lengthened. Both the original production by the native speaker and the manipulated version of the original production were given to the participants in the perception test. If the participants choose the manipulated version for the words with double spelling, this indicates that orthographic forms have an impact on L2 perception. If the participants choose the original production regardless of spellings, this indicates that orthographic forms do not affect L2 perception. For the production test, participants received a randomized written list of stimulus words on paper and produced the words orally within the carrier sentence of "say something again," and in this part the target words is inserted. Responses were recorded using the Goldwave application program with a Sony microphone. The participant recordings were acoustically analyzed by using the program. The duration of the target consonants were measured and compared with that of the native speakers. If duration of the participant is longer, more than 2 times of the duration of the native speaker, it was coded as 0, which indicates target inappropriate production. Otherwise, it was coded as 1, which indicates target appropriate. The overall result is presented in figure 2. The accuracy of total production, this part, total production for single consonant letters was higher than that for double consonant letters. For single consonant letters, the accuracy rates was more than 90%. For double letters, it was less than 80%. Higher accuracy rate for single letters than for double letters was also observed in total perception. For single, it's more than 80%. For double letters, it's far less than 80%. Further, accuracy was a higher accuracy rate for production. This is production was higher than perception, both for single and double consonant letters. In order to find out whether accuracy varied according to consonant letter type, modality, and voicing, an ANOVA with repeated measures was carried out as an omnibus analysis. The three variables were letter type, modality, and voicing. Letter type, there is single letter and double consonant letter. Modality, production and perception. Voicing has voiceless consonant and voiced consonant. The result showed that there was significant main effect of letter type, modality, and voicing. However, no significant interactions were found except the interaction between modality and voicing. The other interactions were not significant. Given the effect of consonant letter type, modality, and voicing, and the interaction between modality and voicing in the omnibus analysis, further statistical analysis are granted to be conducted to assess the individual comparisons within the data set. First, let us examine orthographic effect in details. As in figure 3, individual mean accuracy rates of single consonant were higher than those of double consonant letters, both in production and perception. So this part is far higher than this part. Thus, individual accuracy rates of single versus double letters was submitted to two-tiered t-test. The result of the t-test is given in table 3. The table shows that total accuracy of single letters was significantly better than total accuracy of double letters, both in production and perception. As here, this part. However, this trend is not observed for all the individual tokens. In production, only 4 pairs. This one, the production. Only 4 pairs among 6 pairs showed significant differences between single versus double letter accuracy. Thus, the significant difference between single letters and double letters for the production test was induced by low accuracy of the double letters. This one caused the significant difference between single versus double consonant letters. In the perception test, here, this the blue one, the perception test, only 3 pairs. The accuracy difference for only 3 pairs was significant. Thus, it was low accuracy of double letters like PP, 드드, 그다음에 그그. that was responsible for the perception accuracy differences. Let's move on to modality effect. As seen above, modality effect was found in the omnibus analysis. In figure 4, the production accuracy was ahead of perception accuracy for both single and double consonant letters. Thus, paired two-tailed t-test on the mean accuracy of production and perception were conducted to see whether the mean difference between production and perception accuracy of individual pairs were significant. The results were presented in Table 4. Table 4 shows the modality effect in omnibus analysis is not true for all the cases, while production accuracy was significantly higher than perception accuracy for total single consonant letters. It was not the case for total double letters. So only this one is significant, but this one is not. Among 12 target letters, only this 1, 2, 3, 4, 5 cases for production, and one case was significantly different. This shows that the precedence of production over perception varied with the individual target letters. So not across the board difference, but only depending on the property of the target sound. So we just see the modality effect, and let's move on to voicing effect. Voicing effect was also detected in the omnibus analysis. Figure 5 shows that voiced target accuracy was better than the voiceless target, both for production and perception. So this voiced target is ahead of voiceless target. Thus, the same t-test on the mean accuracy rate of the voiced and voiceless targets were conducted, and the results are in Table 5. Table 5 shows that total voiced target accuracy was significantly better than the total voiceless target accuracy for the production test, but not for the perception test. Only production test, there was significant difference. When pairing the voiced target with the voiceless target, for example, the target sound p and b, and s and d, k and b, only pairs of p, b, k, g, and k showed significant accuracy differences in production. In the perception test, the accuracy difference was significant only for k, g here. So this one is production, this one is perception. Conclusion and discussion. 3 factors influencing the production and perception of English single and double consonant letters were found. The first one is orthographic effect, second modality effect, and voicing effect. Further, the interaction between modality and voicing were found. Let us move on to pedagogical implication. First, spelling pronunciation should be explicitly prevented. Next, perceiving English single and double consonant letters should be more focused than producing it, because production accuracy rate were higher than perception accuracy rates. Last, more emphasis should be placed on voiceless consonants than voiced consonants in producing and perceiving English consonants. Thank you for listening my presentation.